Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. Today I just want to do some simple thing, and what we are going to do is the continuation of the separable differential equation. And we are going to look at the solution to separable differential equation. Is that okay? So this is where you are starting. You are starting with the general solution. So we want to find the general solution of this. So we have dy dx equals xy squared. Is that okay? So this is what we have. Before you can solve something like this, first we have to separate it. So we have look at my previous video. If you know you have not watched it, you can just go there and watch it. If you look at that video, we have talked about the separable differential equation, how to separate it. So with this, you need to separate it first. So let's look at how we can separate this. First, you do cross multiplication. That is going to give us dy equals xy squared dx. Now you divide both sides by y squared, right? So that the x will be attached to the dx, and then this y squared will come to the dy. So when we do that, I have dy over y squared equals x dx. Now at this point, you have separate this differential equation. So we can now solve it, right? Yes. So now let's see. Dy over y squared equals x dx. Is that all right? So looking at this, we integrate both sides. If we integrate 1 over y squared, you know the dy over y squared is the same as 1 over y squared dy plus integral of x dx. So let's integrate this. That will give us negative 1 over y, right? Equals, if I integrate this, I'll have x squared then plus c. Now, somebody might ask, how did I get negative 1 over y? This one is over 2, okay? The reason is that negative 1 over y, I had it from here because if I am integrating this 1 over y squared, so we have to write it as y to the power negative 2. There is no integration, how it works. We add 1 to this, over the negative 2 plus 1. So negative 2 plus 1 will give you negative 1. And here will also give you negative 1 top this. So we have y to the power negative 1 over negative 1, something like this. And you see that here I've integrated it like that. I've written that. So this y, I can write it as y. There's negative here, so negative 1 over y. Because this one can come down because of the negative 1 top there is inverse. So that's how we do integrate it. I brought this c here because c is what? The constant, the arbitrary constant that we have been talking about. So this one is just representing the family of what curves. It can assume any other number. So that is what we have here. Now let's move on to the next example. All good. Let's look at our next example. So this is the next example. Find the general solution of the equation x dy minus y dx equals 0. Is it separated? No. We can make it separable. Okay? Separable in the sense that you want the y to attach to the dy and x to be attached to what? Dx. So let's see. So with this, I can write this one as x dy equals y dx. I have just grouped like terms, or I've sent this one to the other side. And this is what we have. The only way we can do to make the y goes to the dy and the x goes to dx is very simple. Is to divide both sides by x and y. So if I divide here by x y, here to xy, you realize that here this x will go with this, so that I'll have dy over y equals this y will also go with this. They have dx over x. I hope you can see that. Now from this point, I can write this one as 1 over x, okay, 1 over y dy equals 1 over x dx. So I just integrate it. When we integrate 1 over y, we have what? You can guess. So we have ln y equals, when I integrate this, I have ln x plus ln c. Is that okay? Now the constant, you realize that I've attached the ln to it. Yes, it's a constant. That's why we said it can assume any value. And once I'm just getting ln, just attach ln to it to make it beautiful, alright? So looking at this, I can write this one as ln y equals ln x. Okay, let me put it this way. Cx. This is logarithm with natural base. That's why I've written it as ln. If you have a logarithm like this and you are adding it, the property is saying that you just multiply the power. So this will be x times c, or c times x. You know, multiplication is commutative. Since you have ln here, you can take it this way. Like this. Means that this e will cancel this and this e will cancel that. So we have y equals cx. So this becomes the general solution to that problem. It's general solution because we don't know the c. Once you look for the c, or initial conditions are given to you to find the c, that becomes what a particular solution. I hope you understand that. So let's look at another example. Yeah, so let's look at this example 3. For the example 3, there's a question and there's a condition. The condition is that y of 0 equals -2. Indirectly, the question is telling you to find the particular solution. Is that okay? So we are going to find a particular solution to that. But before you can find a particular solution, you first need to know the general solution. Before you can find a general solution, you have to be able to separate the equation or the variable. So that's what you're going to do first. So we have 2x y plus 1 dx equals y dy. I just send this one to the other side. So dividing both sides, you realize that y plus 1 is here and y is here. So all I need to do is just send this one to this place by dividing both sides by y plus 1. So when you do that, you're going to have 2x dx equals y over y plus 1 dy. This is what we have. What is the next thing to do? We integrate them. Is that okay? But when you are integrating it, look at what is here. This one is a fraction. And being fraction, it's not easy to integrate something like this. So what you are going to do is to divide first. So how do we divide this? How do we divide this? It's very simple. Okay, so let's use the long divisions to do that. So first thing, we know that y is outside, then y plus 1. So no, that is not the case. So the y plus 1 being outside, then y, because this one is dividing this. So this one becomes the divisor. Yeah, this one becomes the dividend. Then whatever we get there becomes our quotient, right? So y, I'm going to y 1. 1 times y is y plus 1. So we subtract. Then when you do that, 11 with -1. For this and that to go to 0, so -1. So if you want to write this, it becomes like the quotient plus, but because here is minus, become minus 1 over the divisor, which is y plus 1. Means that I can integrate this one, that's 2x dx, equals, now the integral of this is now this, so it becomes 1 minus 1 over y plus 1. Dx. Is that okay? So if I integrate this, I have x squared, because it will be over 2 and the 2 will cancel this 2. Then if I integrate this, I can separate them, so 1 dx dy minus 1 over y plus 1 dy. So I continue, can decide to put the constant to this. Now this one will be 1. If I integrate this 1, it will become y. If I integrate 1 over y plus 1, it becomes then y plus 1. Okay, so this is what I have as my general solution. Now, the particular solution, the initial condition was given as this. So what am I going to do here? Means that my x is 0, then my y is equals to -2. So what we are going to do, wherever I see x, I put 0 there. So I'm going to have 0 squared plus c equals y is -2, so -2 minus ln y, which is -2 plus 1. So what happens here is that 0 squared is 0, so we have c equals, this side we have -2 minus ln -1. In fact, you don't have logarithm of -1, okay? But because of this absolute, and absolute of every negative is positive, so ln 1. So here it will tend to ln 1. So that gives you c equals -2 minus ln 1. And ln 1 is always 0, means that our c is equals to -2. Is that okay? So if c is -2, then you just come back here and substitute the value of -2 into the c, and that will give you x squared minus 2 equals y minus that. You can just write it. I mean, I won't get space to write it there, but that's how it works. And it's very simple, right? We will solve another particular solution example to it. Just one, then you move forward. Okay, so guys, I think let's look at this one, the last example, then you move forward. So this example is also initial value problem, and is a particular solution because the condition has been given to us. So first thing, you have to be able to separate it. So what you are going to do here, y prime can also be written as dy dx equals, you see this is y, so I can bring it out, leaving x plus 2 all over x. Good. Now at this point, I can bring this one here and divide both sides by y. So that I'll have dy over y equals x plus 2 over x dx. Is that okay? This one I'm trying to separate it, so how I have done it, I think you understand what I've done. Okay. Now, if you have any problem, you can just, write it in the comment section and I will reply to that. So if you have something like this, what you have to do is to integrate, right? So I have 1 over y dy, then I integrate that equals x plus 2 over x dx. My brother, my sister, it will be very tedious for you to integrate this. Okay, so look at what you are going to do. This one, if I integrate this, I know I have ln y equals this have to be like this: x over x plus 2 over x dx. So my ln y equals this gives us 1 plus 2 over x dx. I hope you can see that. Yes. So my ln y equals, if I integrate this one, that gives us x. If I integrate this one, that gives us 2 ln x, then plus c. If you like, you can attach ln to the c. Is that okay? Now let's apply the initial condition where we have y of 1 equals e. And as usual, our x is 1 and our y is what? E. So let's see. Y is e. So I have ln e equals x is 1. So 1 plus 2 ln e plus c. And you know that ln e is 1. So 1 equals 1 plus 2 times 1 plus c. Means that 1 plus 2, because 2 times 1 is 2. So 1 plus 2 is 3. So it means that our c is minus what? Also minus 2. Is that okay? Our c will be minus 2 because ln e is 1. 1 times that is that, right? And at the same time, x is 1. So that is it. C is minus 2. So you just go back here, wherever you see c, this c is now what? Minus 2. And that becomes the particular solution, right? So I think it's very simple and understandable. You can just try your hands on them. Solve it on your own. Pick the question, solve it on your own. Prepare your own notes. It will help you. Thank you very much.